A robotic arm on a construction site in eastern China grabs a chunk of broken concrete off a moving pile of rubble, identifies exactly what it's holding in a fraction of a second, and sorts it into the correct bin before a human worker could have even finished looking at it. That is real. It exists. It's already running on active job sites, and it's just the smallest entry on a list that gets significantly more extreme from here. Before this list is over, you're going to see an entire town that used to be called one of the most toxic places on Earth transformed into a national recycling hub, a battery recycling process pulling out nearly every single atom of critical metal from a dead car battery, and a recovery rate so close to total that it's starting to make traditional mining look genuinely unnecessary. Every figure in this video comes from verified corporate disclosures, government circular economy policy documents, and state media coverage of the actual facilities involved, cross-checking recovery rates and processing volumes across an industry that keeps setting new records took real digging. So if that's useful to you, hitting like and subscribe genuinely helps this channel keep doing it properly. By the time we reach the top of this list, you'll understand why some resource economists now think China's landfills might eventually become less valuable than its recycling plants. Let's start with the robot already working construction sites right now. Number 5 on our list is the intelligent waste sorting robot now deployed directly on Chinese construction sites. And it earns the bottom spot here because, while it's the smallest and least dramatic entry on this list, it's solving a problem that had been genuinely stuck for decades. Here's the backstory. Construction and demolition waste has historically been one of the hardest waste streams on the planet to recycle efficiently because, unlike a neatly sorted recycling bin at home, a pile of demolition rubble is a chaotic mix of concrete, brick, wood, metal, and plastic, all jumbled together, requiring exhausting manual labor to separate by hand. Here's the mechanism behind how an environmental technology company based in China's Jiangsu province solved that problem. The intelligent sorting robot uses computer vision to accurately identify the material type, size, and position of each individual piece of waste, moving past it on a conveyor system, then physically grasps and sorts each piece into the correct category in real time, all happening directly on the construction site itself, rather than requiring the debris to be trucked away first. Here's the number that shows this isn't a small-scale demo. According to the project manager overseeing one deployment, the system processes 500 cubic meters of solid waste across 8 consecutive hours of operation every single day, with a waste processing and recycling rate reaching between 40 and 50%, comparable to filling an entire municipal swimming pool with construction debris, and having nearly half of it converted back into usable material before the sun sets on the same day. Think about what doing this on-site actually saves. By sorting and recycling material directly where the demolition happens, the project avoids the cost and pollution of trucking mixed rubble across the city to a separate processing facility, cutting both debris, clearing fees, and the dust and emissions generated during transportation. But a single robot handling 500 cubic meters a day on one job site is still a fairly modest operation. The next entry on this list took the exact same idea and scaled it up into the first facility of its kind in the entire country. Number 4 is the Guangzhou Residential Decoration Waste Project, and it earns this spot because it holds a genuine national first. It was the first facility in all of China to adopt AI-powered recycling robots specifically for construction and demolition waste at true industrial scale. Here's the backstory. As Chinese cities have modernized rapidly, residential renovation and decoration waste, the debris generated when apartments get gutted and remodeled, has become an enormous and chronically under-recycled waste stream, mixing broken tile, drywall, wood trim, and packaging materials in ways that make manual sorting both slow and inconsistent. Here's the mechanism that makes this facility's approach genuinely more advanced than the single on-site robot covered a moment ago. The plant combines an AI optical sorter, capable of recognizing more than 30 distinct types of recyclable material at speeds up to 5 meters per second, feeding directly into a 3-axis robotic sorting arm that performs up to 5,400 individual picks every single hour, operating continuously under varying light, temperature, and humidity conditions, without the accuracy dropping off the way manual sorting does over a long shift. Here's the number that shows the scale this facility actually operates at. The plant would have been almost entirely landfilled or informally dumped a decade earlier is now being systematically broken down into clean, reusable raw material streams every single year, without needing an army of manual sorters standing over a conveyor belt. But even a national first facility processing renovation debris is still working with waste that was never actually dangerous to touch. The next entry on this list took on a waste stream so toxic it used to be called one of the most polluted places on the entire planet. Number 3 is Guyu. a town in Guangdong province that spent decades as the literal epicenter of the world's informal electronic waste trade. And it earns this spot because its transformation into a legitimate high-tech recycling hub is one of the most dramatic environmental turnarounds in modern Chinese industrial history. Here's the backstory that makes this genuinely remarkable. For years, Guiyu was described in international research literature as one of the most toxic places on Earth, with thousands of small family-run workshops manually dismantling imported electronic waste, using nothing more than open fires and bare hands to melt circuit boards and extract precious metals, filling the town's air with acrid, heavy metal-laden smoke. Here's the mechanism behind how local authorities actually turned that around. In 2015, the local government launched the Guiyu Circular Economy Industrial Park. And rather than simply banning the informal recycling economy that thousands of families depended on for their livelihood, officials used a deliberate carrot and stick approach, offering subsidies of up to 2,000 yuan, or roughly $280, for every makeshift chimney a household agreed to dismantle, while simultaneously banning electronic dismantling anywhere outside the new industrial park. Here's the number that shows how thoroughly that transition actually happened. Between 2012 and 2015, officially confirmed reporting shows 2,469 informal workshops were closed, and over 3,200 makeshift chimneys and gas collection hoods were physically dismantled, with more than 1,200 households ultimately relocating their operations into properly regulated facilities inside the new park. Here's what the park actually looks like today, according to officials who oversee it. Conveyor belts now carry smartphones and laptops through precision dismantling stations, and Guiyu is home to China's first mobile phone, safe recycling and disposal demonstration base, a facility that now processes 12,000 tons of waste circuit boards every single year, extracting heavy metals for centralized, properly contained disposal instead of open burning. Think about what that shift actually represents. A town literally rebuilt from being a symbol of the dangers of unregulated e-waste into a demonstration site the Chinese government now showcases as proof that a circular economy can be engineered on purpose, rather than happening by dangerous accident. But even a fully modernized e-waste town is still working primarily with materials that are relatively easy to physically separate by hand or machine. The next entry on this list is chasing a material buried so deep inside its product that most of the recycling industry hasn't figured out how to reliably get it back yet. Number 2 is China's emerging push into solar panel recycling. And it earns this spot specifically because of the sheer scale of the problem it's racing to get ahead of before that problem actually arrives. Here's the backstory. China currently controls roughly 80% of the world's photovoltaic solar panel supply chain. And after a decade of building out solar power at a pace no other country has matched, the country's own cumulative installed solar capacity had already exceeded 610 gigawatts by the end of a recent year, meaning an enormous wave of aging panels is now approaching the end of its usable lifespan all at once. Here's the mechanism behind why recycling a solar panel is so much harder than recycling a phone or a car battery. A crystalline silicon solar cell is built by fusing together glass, silicon, silver, and aluminum in layers that are extremely difficult to cleanly separate without damaging the most valuable material inside, silicon itself, whose decommissioned photovoltaic panels by 2050, while some Chinese industry estimates, accounting for panels failing earlier than expected, put the figure as high as 66 million tons, comparable to the weight of roughly 6,000 fully loaded aircraft carriers worth of retired solar panels eventually needing somewhere to go. Here's the genuinely promising research emerging from this challenge. Laboratory-scale recycling methods have already demonstrated the ability to recover silicon at purity levels reaching 99.999%, a level of purity clean enough to be reused directly in new solar cells or repurposed as high-performance battery. NOD material with more than 11 times the theoretical energy storage capacity of the graphite currently used in most lithium-ion batteries. Here's the honest concession worth including here, because credibility matters more than a triumphant headline. Researchers themselves have been direct that scaling these high-purity recovery methods economically, rather than just proving they work in a lab, remains a significant unsolved challenge, and China's own solar recycling market, while growing at close to 18% a year, was still valued at under $100 million as of this year, meaning the infrastructure to handle the coming wave is being built well ahead of the wave itself actually arriving, rather than already operating at the scale the problem eventually demands. Before this list reaches its final and most impressive entry, it's worth pulling back, because none of the individual recycling stories covered so far exist in isolation. They're all downstream of a single, deliberate national circular economy strategy. China's own government has set an explicit national target of recycling 19.5 million tons of plastic annually by 2030, and is actively encouraging its leading recycling companies to scale up industrial chemical recycling technologies specifically designed to unlock higher value uses for low-quality plastic waste streams that older mechanical recycling methods simply couldn't handle. Here's the thing that makes that target land differently once you sit with it. This isn't an isolated plastics initiative sitting apart from everything else covered on this list. It's explicitly written into the same 15th five-year plan, covering 2026 through 2030, that also frames circular economy development as a strategic national priority across construction waste, electronic waste, and critical battery materials all at once. This is not a collection of separate environmental programs, each solving their own narrow problem. This is a single, coordinated, industrial strategy treating China's own waste streams as a genuine domestic resource base, precisely because so much of the raw material China's manufacturing economy depends on, silicon, lithium, cobalt, nickel, copper, has to otherwise be imported from mines controlled by other countries entirely. And once you see that strategic logic driving the whole list, the final entry, a recycling process now recovering critical battery metals at a rate that's edging remarkably close to total, complete recovery, stops looking like a corporate efficiency milestone and starts looking like exactly what it is. The clearest proof yet that China intends to mine its own landfills rather than keep depending on someone else's ground. Number one is Brump Recycling, a subsidiary of CATL, the world's largest battery manufacturer. And it takes the top spot on this list because its recovery numbers are, at this point, edging so close to total, complete extraction that they're starting to make the entire concept of waste feel almost obsolete for this specific material stream. Here's the backstory. Brump was originally founded in 2005 as a consumer lithium battery company, shifted its focus specifically to power battery recycling in 2011 as China's electric vehicle boom began accelerating, and became a CATL subsidiary in 2015, putting the world's dominant battery maker directly in control of what happens to its own batteries once they finally wear out. Here's the mechanism behind the technology that separates Brump from ordinary battery recycling. The company's proprietary directional recycling technology, known as DRT, combines intelligent disassembly, hydrometallurgical processing, and material restoration into a single integrated pipeline, specifically engineered to pull critical metals back out of a dead battery in a chemical form pure enough to be fed directly back into new battery production, rather than requiring those metals to be re-refined from scratch the way most recycled materials do. Here's the number that makes this genuinely historic rather than just impressive. Brump has achieved a recovery rate of 99.6% for nickel, cobalt, and manganese, alongside 96.5% for lithium. Figures that don't just beat the industry's traditional benchmarks, they annihilate them, since conventional pyrometallurgical recycling methods typically recover only around 95% of nickel and cobalt, while losing the vast majority of lithium entirely, often reclaiming as little as 25 to 30% of it due to material losses during processing. Think about what that gap actually means in practice. Traditional recycling was effectively throwing away roughly 70 cents of every dollar's worth of lithium inside a dead battery, while Brump's process now keeps back almost all of it. Here's the number that shows this is already operating at genuine industrial scale rather than remaining a laboratory curiosity. In a single recent year, Brump processed over 120,000 tons of used batteries and produced 17,100 tons of recycled lithium salts, a volume the company itself says is roughly equivalent to reusing the battery materials from up to 300,000 electric vehicles, comparable to recycling the equivalent of an entire mid-sized American city's fleet of personal cars in just 12 months. Here's what makes this genuinely different from every other entry on this list. This isn't just an environmental win, it's a direct hedge against China's own resource dependency, specifically reducing the country's reliance on imported nickel, cobalt, and lithium at exactly the moment global demand for those same materials is projected to surge as the electric vehicle and battery storage industries keep expanding worldwide. Here's the honest concession worth ending on, because credibility matters more than a perfect headline number. Recovery rates this high still depend heavily on batteries being collected, transported, and processed through Brump's own formal channels, rather than lost to informal lower recovery recycling operations elsewhere in the supply chain, meaning the real-world environmental payoff of this technology scales directly with how much of China's total battery waste actually makes it into a system like this one, rather than a cruder alternative. That is exactly why it's here at number one. It isn't just the most efficient recycling process on this list, it's the clearest sign yet that China's next major source of critical minerals might not be a mine at all. It might be a warehouse full of dead batteries. So here's the full picture, start to finish. A single AI-powered robot is already sorting construction rubble directly on active job sites, recovering up to half of every truckload before it ever leaves the property. The Guangzhou Residential Decoration Waste Project scaled that same idea into China's first true industrial-grade facility for construction waste, processing enough debris annually to fill hundreds of Olympic swimming pools. Guyu turned from one of the most toxic places on the planet into a national recycling showcase, thanks to a deliberate policy that closed thousands of dangerous informal workshops and rebuilt the entire local economy around properly contained, high-tech processing instead. China's emerging solar panel recycling push is racing to get ahead of a coming wave of tens of millions of tons of retired panels before that wave actually arrives. And Brump's battery recycling technology is now recovering critical metals at rates so close to complete that traditional mining is starting to look genuinely inefficient by comparison. What you're actually watching across this entire list is the same shift that happened to the oil industry a century ago, when waste byproducts from refining crude oil, once simply burned off or dumped, eventually became valuable feedstocks for entirely new industries, once someone finally bothered to look closely enough. China is applying that exact same logic to its own garbage, treating landfills, dead batteries, and retired solar panels less like a disposal problem and more like an untapped domestic mine that happens to already be sitting inside the country's own cities. If breakdowns like this, the real technology and the real numbers behind China's biggest circular economy pushes, are useful to you, hit like and subscribe, because there's more of this coming, including a closer look at what happens once China's solar panel recycling industry actually has to handle the tens of millions of tons of waste headed its way in the coming decades. So here's the honest question for the comments. Does recovering 99.6% of a battery's critical metals change how you think about the long-term supply of materials like lithium and cobalt? Or does the real story only start once recycling like this becomes the default everywhere, not just inside a handful of flagship Chinese facilities? I rate every single one.